a world where technology is critical for almost every industry, DevOps engineers are at the forefront of optimizing software delivery processes, improving software quality, and ensuring that businesses can rapidly adapt to changing market conditions. Their role is crucial in achieving efficiency, reliability, and innovation in the world of software development and IT operations. It's no surprise that their expertise is in high demand, with their contribution reflected in the compensation they receive. For instance, in India, a DevOps engineer typically earns an average annual salary of 7,50,000 rupees, whereas in the United States, the average yearly wage for the same role is $138,000. Hey there, welcome to our DevOps interview question sessions. So if you're getting ready for a DevOps job interview or just curious to learn, you're in the right place. So before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, visit the Edureka website for training and certification courses, the link to which is in the description box below. So first, let us understand what is DevOps. DevOps, a combination of development and operation, is a set of practices that aims to improve and automate the collaboration and communication between software development and IT operation teams. The primary goal of DevOps is to streamline the software development and delivery process, enabling organizations to deliver high-quality software more rapidly and efficiently. And who are DevOps engineers? A DevOps engineer is a professional who combines expertise in software development and IT operations to streamline and improve the software development and delivery process. DevOps engineers play a crucial role in implementing DevOps practices within organizations, bringing the gap between development and operation teams to achieve more efficient and reliable software delivery. And now, how can you become a DevOps engineer? So it's all about continuous learning. Start with a strong foundation in areas like software development and system administration. Learn key tools like Git, Jenkins, Docker, and Kubernetes. Certification can also help you stand out. Now, let's get started with the beginner level DevOps interview questions. And the first question is, what is DevOps and why it is important? Since we have already went through what is DevOps, let us understand why it is important. So DevOps is essential for organizations aiming to stay competitive by delivering high-quality software faster with improved collaboration, automation, and a focus on customer feedback and security. And the next question is, name the core principles of DevOps: collaboration, automation, customer-centric action, responsibility throughout the lifecycle, database decision-making, and constant improvement. And the next question is, which are the top DevOps tools? And the top DevOps tools are Jenkins, Docker, Ansible, Puppet, Chef, Git, Selenium, and Terraform. Up next we have, what are the different phases in DevOps? The different phases in DevOps are plan, code, build, test, release, deploy, operate, and monitor. The next question is, how is DevOps different from the Agile methodology? DevOps and Agile are complementary methodologies with different scopes and focuses. So first, DevOps focuses on the entire software delivery pipeline and involves both development and operation teams, aiming to automate and streamline processes. Agile, on the other hand, focuses on the development phase, emphasizing iterative development, customer collaboration, and flexibility within the development team. So both methodologies seek to improve software quality and customer satisfaction, but address different aspects of the development process. Next, explain CI and CD. CI stands for continuous integration. So it is a process of frequently and automatically integrating code changes made by different developers into a shared repository. And each integration triggers an automated build and a series of tests to catch and fix issues early. And CI ensures that the code base is always up to date and working smoothly. Whereas CD stands for continuous deployment. It's the automatic deployment of code changes to production or staging environments after they pass the CI process. CD ensures that the new features and bug fixes can be efficiently and reliably delivered to users, often without manual intervention, while maintaining a high level of quality and stability. And the next question is, name some popular config management tools. And the tools are Ansible, Puppet, Chef, SaltStack, CF Engine. The next question is, what is infrastructure as code? Infrastructure as code is a practice in DevOps and IT operations that involves managing and provisioning infrastructure resources using code and automation. Instead of manually configuring servers, networks, and other components, ISC treats infrastructure setup and management as if they were software. In short, instead of setting things up manually, you write scripts that tell the computer how to do it automatically. So this makes it easier to control, change, and replicate your infrastructure, like creating a copy of a setup exactly as it was before. And the ninth question is, what is the role of AWS in DevOps? In DevOps, AWS play a crucial role by offering cloud infrastructure and services that allow teams to automate provisioning, scale resources dynamically, and implement serverless and container solutions, all while streamlining CI/CD pipelines and providing robust tools for monitoring, security, and compliance, making it a go-to choice for managing databases and facilitating global deployments, while also offering seamless integration with an extensive ecosystem of DevOps tools. Next, name 3 important DevOps KPIs. The 3 important DevOps KPIs are deployment frequency, lead time for changes, and mean time to recovery, that is MTTR. Next, explain automated testing in CI/CD. Automating testing in CI/CD means using automated tests to check code changes for issues and quality as they are integrated and deployed. It's a quick and consistent way to catch problems early, maintain code quality, and ensure reliable software release. Up next, we have explain Jenkins pipelines. Jenkins pipelines is a powerful feature of Jenkins, an open source automation server. It allows you to define and automate the entire software delivery process as code, making it more flexible and easier to manage. In other words, Jenkins pipelines offer a way to define, automate, and manage your software delivery process in code, providing flexibility, repeatability, and scalability to your CI/CD workflows. Next, what is configuration management? Configuration management is a systematic process that involves identifying, documenting, controlling, and tracking changes to various components of a system or product to maintain its consistency, reliability, and integrity over time. And the next question, what are the benefits of using version control systems like Git in a DevOps environment? Version control systems like Git benefits DevOps by enabling collaboration, versioning, continuous integration, rollback, code quality control, documentation, branching, security, portability, and constant monitoring. They streamline development, improve code quality, and support DevOps practices for efficient and reliable software delivery. Next, what is the role of containers in DevOps? Containers in DevOps are lightweight, standardized packages that bundle applications and their dependencies for consistent and portable execution. They enable resource-efficient isolation, scalability, and rapid deployment, facilitating seamless automation and orchestrations in the software development and delivery process. Containers align with DevOps principles, enhancing efficiency and reducing deployment's complexities. Now, let's move on to the intermediate and advanced level DevOps interview questions. And the first question is, what is the blue-green deployment pattern? The blue-green deployment pattern is a deployment strategy used in DevOps to minimize downtime and reduce the risk of releasing new versions of an application. This approach involves maintaining 2 separate environments, typically referred to as blue and green, where only one serves as the active production environment at any given time. The pattern is executed as follows. The blue environment is the current production, green environment is new version, then testing and validation, traffic switching, and later ongoing monitoring. And the second question is, define shift left in DevOps. Shift left in DevOps refers to the practice of moving activities such as testing, validation, and quality assurance earlier in the software development process. Rather than conducting these activities mostly in the later stages or during deployment, shift left advocates starting them as early as possible in the deployment lifecycle. So this approach helps identify and address issues sooner, enhancing software quality, accelerating development, and reducing the cost and effort required to fix problems. It also emphasizes collaboration between development and testing teams, with an increased focus on automation and continuous feedback to improve overall software development efficiency and quality. Next, how do you automate software builds? First, choose a build automation tool, followed by version control to store the source code and create a build script or configuration file. Set up continuous integration server like Jenkins, then configure your CI server to trigger a build. Use your build automation tool to manage project dependencies, and later ensure that the build environment is well defined and consistent. And after that, integrate automated testing and quality checks into your build process. After a successful build, your build automation tool should create an artifact such as executable files, libraries, or deployment packages. And finally, deployment. Next, we have why is continuous testing important for DevOps? So it is important because it identifies issues early, provides rapid feedback, ensures software quality, include automated regression testing, incorporate security and compliance check, reduce risk, accelerate releases, improve collaboration, support shift left, and optimize testing resources. And the next question is, explain the master-slave architecture of Jenkins. In the Jenkins master-slave architecture, Jenkins has a central controller called the master, and multiple worker mission refers to as slaves. The master is responsible for managing job scheduling, configuration, and storage of job definitions and build history. On the other hand, the slaves are worker missions that execute tasks. They run Jenkins agents which communicate with the master, receive job instruction, runs the jobs locally, and report the job progress and result back to the master. And the next question is, explain the two types of Jenkins with their syntax. Jenkins provide two primary ways to define and configure pipelines. They are declarative and scripted pipelines. Both are used to create CI/CD pipelines, but they have different syntax and approaches. So declarative pipelines are designed to provide a simpler and more structured way to define pipelines. They use a more human-readable and concise syntax, making them easier to read and maintain. And the syntax is, so in this example, a declarative pipeline is defined with three stages, that is build, test, and deploy. Each stage contains a series of steps to execute. Whereas the scripted pipelines provide more flexibility and are based on the Groovy scripting language. They are suitable for complex and advanced use cases but have more challenging learning curve compared to the declarative pipelines. So in this example, a scripted pipeline is defined using a node block. So inside the node block, stages are defined with explicit steps. Scripted pipelines provide more fine-grained control over the build process and can include conditional logic and custom functions within the Groovy. And the next question is, how to automate testing in DevOps lifecycle? So to automate testing in DevOps lifecycle, choose the right testing tools and framework, then integrate testing into your CI/CD pipeline, write and version automated test scripts, then manage test data and environments, enable parallel test execution, then provide real-time feedback and reporting. Later, encourage shift-left practices, continuously improve your testing process, and in result, automatic testing speeds up feedback, reduces defects, and enhances software quality and security. And the next question is, what are the key features of Docker and how it is used in containerization? The key features of Docker are easy and faster configuration. So Docker simplifies application configuration by packaging everything needed into containers, making it easier to set up and manage application. Next, ability to reduce size. So Docker uses efficient storage and layering, reducing image sizes and improving storage efficiency, so which is particularly useful for distribution and deployment. Next, increase productivity. So developers can work in consistent and isolated environments, speeding up development and testing cycles while reducing any issues. And then we have application isolation. So Docker containers isolate applications and their dependencies, preventing conflicts and ensuring that each application runs independently. Next, Worm. So Docker Worm is Docker's native clustering and orchestration solution for managing and scaling containerized application across multiple hosts. And then we have Routing Mesh. Docker Swarm provides built-in load balancing and routing for services running on a cluster, simplifying the setup of highly available applications. And then we have services. So Docker Swarm services allow you to define and deploy multi-container applications as services, making it easy to manage complex applications. And finally, we have security management. Docker offers various security features, including user namespace, capability control, and image scanning to enhance the security of containerized applications. Next, discuss the challenges and best practices for managing secrets and sensitive information in DevOps. So the challenges are, first we have security. So keeping secrets safe from unauthorized access. Next, automation. So integrating secrets into automated processes. Next, access control. Managing who has access to the secrets. And then rotation. So regularly changing and updating secrets. And finally monitoring, tracking and auditing secret access. The best practices are use secure tools, no hard coding, role-based access, rotation, encryption, audit logs, education, and finally regular testing. And the 10th question is explain the principle of site reliability engineering, that is SRE. SRE is a discipline development by Google that combines software engineering and IT operations to create a balance between reliability, availability, and efficiency in large-scale complex systems. The key principles of SRE are embracing risk. So understand and manage risk to balance reliability and innovation. Next, service level objectives. Set measurable reliability targets based on user expectations and work to meet or exceed them. And then we have toll reduction. Automate repetitive manual tasks to reduce human errors and free up time for strategic work. And next we have monitoring. Implement robust monitoring to detect issues and understand system behavior. And the next key principle is release engineering. So collaborate to ensure stable, non-disruptive releases and deployments. Next, automation. So automate routine tasks for consistency and efficiency. And finally, simplicity. So keep systems simple to reduce complexity, which can lead to increased risk. And the next question is, how will you secure Jenkins? Some best practices for securing Jenkins include access control. So use strong passwords and set user permissions. Next, server security. So keep Jenkins and its plugins up to date. Limit physical and network access. Then, plugin and build security. So update plugins regularly and isolate builds in secure environment. And then configuration and secrets. So review and protect job configuration. Safely store secrets using the credentials plugins. And then we have backup and monitoring. So backup Jenkins data and set up logs and monitoring. Then secure communication. So use HTTPS and SSL certifications. And then API tokens. Use API tokens for programmatic access. Then security testing. So integrate security test into your CI/CD pipelines. The next question is explain the difference between git fetch and git pull. So git fetch is used to retrieve changes from a remote repository without merging them into your local branch immediately. And after a fetch, your local branch remains unaffected and doesn't automatically update to reflect the changes from the remote repository. And then fetching separates the process of retrieving changes from the remote repository and integrating them into your local branch. It's a safe way to see what's new without affecting your local work. And then comparison. So fetch allows you to compare your local branch with the remote branch to understand the difference before deciding whether to merge or rebase. And best practices, often used in combination with git merge or git rebase to update the local branch with the changes retrieved using the fetch. Next, git pull. The pull concept. Git pull combines the fetch and merge actions into a single command. So it retrieves changes from a remote repository and immediately merges them into your local branch. And then after a pull, your local branch is automatically updated to include the changes from the remote branch. And then git pull is more convenient for quickly updating your local branch but may potentially lead to unexpected merge conflicts if not used carefully. And then less control. It provides less control over when and how the changes are integrated into your local branch compared to Git fetch. And finally, the best practices. Generally used for simply updates and when you are certain that merging the remote changes won't lead to conflicts or issues. Next, explain some basic Git comments. First, we have git init. So, initializes a new Git repository in the current directory, creating a hidden .git directory to store repository data. Next, git clone. Creates a copy of a remote repository on your local machine, allowing you to work with the project locally. Next, git add. So, stores changes for commit. You can specify individual files or directly to state. Next, git commit message. Commit states changes with a descriptive message to the repository history. Then, git status. Displays the status of your working directory, showing which files are modified, staged, or untracked. Next, git log. Shows a history of commits, including commit messages, authors, dates, and commit hashes. Then, git branch. List all the branches in the repository, indicating the current branch with an asterisk. And then we have git checkout. So this changes to the different branch or a specific commit. You can create a new branch by specifying its name. And then we have git pull. So this fetches changes from a remote repository and merge them into the current local branch. And finally we have git push. Sends your local commits to a remote repository, updating the remote branch with your changes. Up next we have mention some of the useful plugins in Jenkins. Some useful plugins commonly used in Jenkins are Blue Ocean, so provides a modern user-friendly interface for creating, visualizing and managing Jenkins pipelines. Next, Git plugin. So this integrates Git version control with Jenkins, enabling the automatic triggering of builds on code commit, branch management and Git-based project configuration. And then we have Docker plugin. So this allows you to build, publish and manage Docker containers as part of your Jenkins pipelines. And then we have pipeline plugins. Facilitates defining and managing complex, multi-step build and deployment pipelines using the pipeline domain specific language, that is DSL. And then we have HTML publisher plugin. So publishes HTML reports generated during builds, making them accessible through the Jenkins interface. Next, Maven integration plugin. So streamlines the use of Apache Maven as a build tool, making it easy to build, test and deploy Maven projects. Next, Jira plugin. So provides integration with Atlassian Jira, allowing you to create issues and update Jira issues directly from Jenkins jobs. And finally, we have Amazon EC2 plugin. Enables Jenkins to dynamically provision and manage Amazon EC2 instances as build agents to handle job workloads. And the next question is, how do you go about creating a backup and duplicating files in Jenkins? Creating a backup and copying files in Jenkins is a straightforward process. To create a backup of your Jenkins configuration, you need to periodically back up your Jenkins home directory. So this directory contains critical components such as your build job configuration, slave node configuration, and build history. So to perform a backup, simply make a copy of this directory. If you want to copy specific job configuration or replicate a job, you can do so by copying the respective job directory. So this allows you to create duplicates of jobs or change their names if needed. And with this, we have come to the end. I hope you have enjoyed the video. And if you did, make sure to like and subscribe to our YouTube channel. Thank you for watching and keep learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!